This lecture is on bone health, including calcium, vitamin D, magnesium, and phosphorus. Today we'll be talking about how calcium, magnesium, and phosphorus make up bone in mineral content. Bone is also made of some proteins as well as bone marrow, where our blood cells are produced. Now, we've talked about minerals a little bit, and when we look at minerals, they can be classified into two different types: major minerals and trace minerals. Major minerals, as we've mentioned before, are present in the diet in 100 milligrams or more per day for the RDA for adults, or they're present in the body making up more than 0.01% of our body weight. On the other hand, trace minerals are needed in less than 100 milligrams each day, according to RDAs or AIs, and they're present in the body in less than 0.01%. The minerals that are major minerals mostly act in bone health or act as electrolytes, or both. A major mineral involved in bone health is calcium. Calcium is regulated by a number of hormones. When blood calcium is low, the parathyroid gland releases PTH, or parathyroid hormone. PTH then promotes calcium reabsorption by the kidney, helping to maintain more calcium in the body and not excreting it through the urine. PTH also stimulates the activation of vitamin D by the kidney, which then in turn increases gene expression of the intestinal mucosal cells that will absorb the calcium into the body. This will help to create a normal blood calcium level. On the other hand, if blood calcium is high, the thyroid gland will secrete calcitonin. Calcitonin inhibits calcium release from the bone, and PTH stimulates calcium release from the bone. So therefore, PTH, as well as calcitonin and vitamin D, work in synergy in order to regulate the amount of calcium that's present in the blood. Calcium in the blood is going to act as an electrolyte, helping us especially to conduct muscle contractions. Vitamin D, as we mentioned, is really important in regulating blood calcium in terms of the calcium from the bone as well as the calcium absorption in the intestines. Vitamin D can be consumed in food or created by exposure to ultraviolet light. When UVB rays hit the skin, cholesterol is converted into 7-dehydrocholesterol. 7-dehydrocholesterol is then converted into vitamin D3 or cholecalciferol. Cholecalciferol heads to the liver where it's converted to 25-hydroxyvitamin D3. Then, in the kidney, 25-hydroxyvitamin D is converted into 1,25-dihydroxyvitamin D. This form of vitamin D is the one that performs biological functions such as increasing the intestinal absorption of calcium. As you can see here, at the kidney, active vitamin D will help to act with PTH to increase calcium retention, so less calcium is lost in the urine. Active vitamin D at the intestines is going to increase absorption from calcium from the diet. And at the bone, active vitamin D will help to act with PTH to increase bone breakdown, releasing calcium into the blood. All of these factors together are going to work in order to increase blood calcium. As we look at calcium and bone health, there are two components called osteoblasts and osteoclasts that help to increase the calcium deposited in the bone or to cause bone resorption, or carrying calcium away from the bone. At the resting bone surface, we have osteoblasts. Active osteoclasts will attach to the bone surface and break down or resorb bone. Pre-osteoblasts will then move in to begin rebuilding bone. Active osteoblasts will then engage in bone formation. So we have this constant bone remodeling going on over our lifespan. Estrogen is an important hormone needed for this process in terms of osteoblasts building bone. And as we'll see in a minute, over the lifespan, there's a natural increase in bone mineral density up to the age 30 or so. Then we level off and we'll see a sharp decrease in bone mineral density around menopause. As we age, osteoporosis becomes a risk factor. When weakened by osteoporosis, the front edge of the vertebrae collapses more than the back edge, so the spine bends forward, and this creates what we call a Dowinger's hump. In addition, hip fractures are also of great risk in osteoporosis. All osteoporosis really means is that we have less grams per centimeter squared of bone, which means that our bones are less dense or more porous. As I mentioned before, over the lifespan, bones are going to increase in mass and in density, and then bones will decrease in density as we get older. As you can see in this figure, in total growing children, bone mass increases and bones grow larger. During puberty, as sex differences occur and hormones are a little bit different in terms of estrogen and testosterone production, bone mass will increase rapidly, and in males, the peak bone mass ends up being higher than in females. Both men and women, after around age 35 or so, are going to start losing bone mass, and then, as I mentioned before, you can see there's this sharp decrease in bone mass in females once they lose estrogen in their bodies during the menopausal years. Now, I mentioned before that vitamin D is going to play a role in increasing gene expression in order to allow calcium to transport into the intestinal mucosal cells at a more rapid rate. So as you can see, high concentration of calcium is going to allow absorption into the intestinal mucosal cells by passive diffusion, which means from an area of higher concentration to an area of lower concentration without the need of a protein carrier or without the need of energy. On the other hand, if there's low to moderate concentrations of calcium in the intestinal lumen, you'll end up seeing that vitamin D will turn on the synthesis of active calcium transport proteins. This will require both the transport protein as well as ATP or energy in order to get that calcium into the blood vessel. Calcium transport proteins are going to shuttle calcium from the lumen across the mucosal cell, and then a calcium pump that requires ATP is going to move calcium from the mucosal cells into the bloodstream. Now, when we look at calcium in the diet, and as I mentioned before, in those peak years of bone mass growth, calcium in the diet has really decreased in terms of milk consumption over the past number of years for a variety of reasons. We often see youth drinking Coca-Cola or other soft drinks rather than drinking low-fat milk, and this can have a really big change in terms of vitamin and mineral content that are related to bone. So as you can see here, a soft drink contains 0 milligrams of calcium, whereas a glass of an 8-ounce low-fat milk is going to have about 300 milligrams of calcium. Furthermore, there's only 45 grams of phosphorus, another bone-building nutrient in cola, and then you have 235 grams of phosphorus in the low-fat milk. And in addition, there is some vitamin D in the milk and none in the soft drink. And then the soft drink also is going to contain caffeine as well as a lot of empty calories just coming from added sugar, which then can cause bone to break down as well. So the cola with the caffeine content, added sugar content, and lack of nutrient density is going to be a really poor choice for bone health, especially in those really pivotal years, especially during puberty, where bone mass is increasing really rapidly. Vitamin D in the diet is pretty hard to come by. We have vitamin D in milk. It's fortified in milk, so it's not naturally found there. We have a little bit of vitamin D in things like liver and chicken. There's a good amount of vitamin D in salmon and a moderate amount of vitamin D in eggs. But as you can see here, vitamin D isn't super widespread in the diet, so if we're not being exposed to UVB rays, which here in New England we aren't for about half of the year, we really need to make sure that we're taking in vitamin D in some sort of supplemental form. It's also a nice excuse to go somewhere warm in the winter, just for a week or two, to get those UVB rays to make our vitamin D. Now, when we look at calcium supplementation, There are some different descriptors on food labels that will explain how much calcium is in those foods. So if something says high calcium, rich in calcium, or excellent source of calcium, it means that that food contains 200 milligrams of calcium or more per serving. If it's a good source of calcium, it contains 10 to 190 milligrams of calcium per serving. So you can see that that spans a really wide range. And then if there's more or added calcium, it means that it has at least 100 milligrams more calcium per serving than a reference food. So the more or added calcium is a good example of calcium fortified orange juice. When you're choosing a calcium supplement, there's a variety of different factors that you want to take a look at. So 500 milligrams taken twice a day will provide 100% of the RDA for men ages 19 to 70 and women's ages 19 to 50. Taking the 500 milligrams twice a day is helpful because calcium is absorbed best when taken in doses of 500 milligrams or less. Also, you want to make sure you choose calcium supplements that contain either calcium carbonate or calcium citrate. You want to avoid the products that contain aluminum and magnesium because they can deplete calcium. Also, make sure to choose a supplement with vitamin D to make sure that that vitamin will be available in order to enhance calcium absorption through active transport. So as we talk about the different types of minerals in the diet, we can see that calcium is pretty widespread in foods. In addition to having it in supplements or having it fortified in foods, you can see that calcium is pretty widespread in terms of the protein group found in some nuts and seeds and beans, as well as a little bit higher in tofu and sardines. And then it's going to be found, of course, in dairy, where we typically talk about it. And then it's also found in greens, but again, it's going to be depleted a little bit by the tannins, phytates, and oxalates that are in both greens and grains, so that's of a little bit of concern. Phosphorus, we mostly are going to be talking about when we talk about phospholipids and ATP. Phosphorus is found very widespread in the body in addition to calcium. So when we look at phosphorus and calcium in terms of how much of each to consume, phosphorus is even more widespread in the diet, whereas calcium is a little bit less. And we really want to balance our phosphorus and calcium intake in order to optimize our bone health. So just make sure you're having enough calcium and not just too much phosphorus by really balancing out the dairy products, as well as things like sardines, as well as things like dark leafy greens and grains. And if you choose to have a vegan diet, having some supplementation of calcium-rich foods might be necessary. And the last nutrient I want to talk a little bit about is magnesium. Now, as you can see here, magnesium is actually found in a number of different foods that are, usually it's what we think of as being really healthy foods. So if you're eating a vegan diet, magnesium will actually be really high in your protein sources like nuts and seeds and beans, as well as in your greens and your whole grains. So it's also important to get enough magnesium in the diet, both for its function as an electrolyte, as well as its function as a bone health nutrient and its function as a cofactor in a variety of reactions throughout the body. So in conclusion, making sure that you have enough calcium, phosphorus, magnesium, and vitamin D is really important to optimize bone health. Making sure that you're protecting yourself against osteoporosis through both weight-bearing activity as well as dietary factors can be really important for a long and healthy life that's free of hip fractures and free of injuries to the vertebrae.